Hello everyone, I am Shashank Singh, a junior student at IIT BHU, Varanasi in India. This is my solution for building the next gen agentic app with GraphRag and NVIDIA QGraph. And my team name is TravelMate. So what is TravelMate? Hey, my dad got a sponsored trip to India, but I don't know where to visit. OMG, haven't you heard of TravelMate? No, what's that? It's an awesome tool to plan trips. Let me tell you more about it. So, talking about the business problem analysis and its breakdown. So, the main challenge here is to decide where to visit because of a lack of reliable and relevant travel information. Trusted platforms give generic recommendations, and there's very less opportunities for personalized tools. The need is for a smart tool to deliver customized, trustworthy itineraries, must combine the user preferences, that is, the dates, regions, interests, with real time accurate data, and a seamless solution for the tailored travel experiences. So, here we introduce TravelMate, which is a smart travel planning tool designed to enhance your journey. Whether you are visiting a city or exploring a new country, TravelMate helps you discover the best places to visit. First of all, it has the personalized picks. It suggests places to visit within a city, country, based on your preferences. The destination insights, it offers details about popular attractions, hidden gems, and must visit spots in any location. And the plan highlights, it offers an itinerary placed on the basis of world data to help users start their day off smartly. So the key components that I have used are ArangoDB, which is a multi-model database supporting graph, document, and key value data with ArangoDB query language for querying. The Flask REST API is a lightweight web service that connects the Python Flask backend to the front end. The Network X QGraph is a Python library for creating, analyzing, and visualizing the graphs and the complex networks. Knowledge Graph is a structured database that connects and organizes information about the places, moods, user preferences, etc. So, how I curated my data set? First of all, I take the information from the user as the destination location. Then, using the Google Maps API, I find the best 20 places in those locations. Then, using the Wikipedia pages, I fetch information about each of those 20 places and give it to the Gemini API. The Gemini API finds the entities in the information given and creates a pandas data frame with the nodes and the edges. This is then converted into a knowledge graph using Network X. These are some dataset sample points. Talking about the approach pipeline, the step one is to the user input details like the mood, preferences, or destination ideas. The step two, the input is sent to the system's gate to determine if the location has been searched before or not. If yes, implement a RAG solution to query on the knowledge graph. If no, then create a knowledge graph of that location and then implement the RAG solution to that query of the knowledge graph. Then step 4 is to provide the tailored travel suggestions based on the queried knowledge graph. And after that, we develop an itinerary and display it to the user. So now talking about creating and querying the knowledge graph. This is the front end that we can see over here. And as I talked about, the destination passed through the Google Maps API and provides a list of the top notable places. After this, it is then sent to the Wikipedia APIs to fetch a brief description of the places. After getting these all information, we pass it to a large language model to generate the equal queries and network X commands. These are then fed into to the network X to create a database, which is a graphical database that we use it as a knowledge graph. Thank you. Now let's switch on to the demo. So now this is our front end. So this is the source location. Let's put it as Varanasi. Now for the destination location, either we can put something that's already been searched for or other. And for other, it may take about 3 to 4 minutes to generate. So let's now go on with something like Bombay. The departure date may be 11. The return date may be 16th. The budget may be 10,000 rupees. And for the interests, let's define our interest here. These are some of the places that someone can visit if he has no idea about which destination location he should search for. So let's click on the recommend places button. Now this would take about 30 seconds, and this depends upon the type of backend that we are using. It can be either CPU or GPU. GPUs are comparatively very fast compared to CPUs, and also it depends on the amount of data that's present into the knowledge graph. If it's huge, then the amount of time can be significantly high. Now, as we can see, there are some places that are already being marked. For example, this Gateway of India, Bombay, because it's near the seashore. Similarly, the Marine Drive, and there are some places that aren't marked yet. Now we can add some places that we want to visit. For example, the Canary Caves that we want to visit, the Love Mumbai. We can also search for some of the details over here, and if we want to visit, we can add this. Similarly, some more choices that we want to make. After making all the suitable choices, we can then proceed on to click the itinerary planner. This is something that will define the type of itinerary that you should follow, and we can wait about for about 10 seconds to get the itinerary. So as we can see, our personal itinerary has been generated. Now this is the first place that we should visit, the Chhatrapati Shivaji Maharaj Vastu Sangrahalaya. These are some of the details about those places. These are the timings that we should follow, the duration that it would take for visiting that place, the transportation, the favorite transportation that's used by people, the activities, for example, the exploring the exhibits, learning about Indian history and art. These are some notes, like there can be an entry fee applicable for this place. Similarly, we should allow ample time to explore the vast collection, and we should consider hiring a guide for a more in-depth experience. As we can see, there's an arrow pointing downwards showing us the second point. This is the Gateway of India, Bombay. This one was 10 a.m. to 5 p.m. For Tuesday. Then it can be the late afternoon, the Tuesday till the sunset, and it would take about 2 to 3 hours. Similarly, this is the Marine Drive that would take about 1 to 2 hours in the evening on Tuesday after the Gateway of India. Then we can go on to the Canary Caves on Wednesday. It would take about 4 to 5 hours, and the transportation medium can be a taxi or a local train to Borivali, then bus or auto rickshaw to the caves. And as we can see, finally it ends with late afternoon, early evening on the Friday, and hence we can conclude our journey from Tuesday to Friday as planned by our itinerary planner. That's all from my side. Now let's move on to see the knowledge graph. So this is the RangoDB web interface. Now, as we can see, there are 273 nodes and 297 edges over here, and these nodes are the name of some places. For example, we can see this is the Sri Kashi Vishwanath temple, which is located in Varanasi, and for the attributes, we can see there's a name attribute which links to the Sri Kashi Vishwanath temple, and the type of it is a type of tourist attraction. Then we can move on to other places. For example, India Gate, as we have seen for Bombay. These are some of the attributes that are related to India Gate. And this is also related to New Delhi by these two edges. Now we can also learn about the edges from the relation located in and near. These are some attributes that are related to these edges. And yeah, that's all from my side. So now let's proceed on with the code overview. So this is my solution.ipynb Python notebook. These are some steps to make a virtual environment and setting up the virtual environment. We can install these of the dependencies. This is for running the NVIDIA GPU and the QGraph. These are some other dependencies that are needed only when we are using the QGraph. These are the imports that we need to make. This is the Wikipedia API that fetches the information about a specific page or a location. This is the Maps API. This gives a list of SZ number of places in a city or any destination location. This is the Get Wikipedia description for places, combining the above two functions. This is the Call Gemini API function. This is just an integration of the API of provided by Gemini. We can set these attributes over here. This is extract knowledge from Gemini. This is to convert the unstructured textual data into structured format. The format that we are preferring over here is the TSV, that is the tab separated values. Now converting the tab separated values into a knowledge graph. Sanitize keys is a function to remove any spaces in between. Knowledge graph from data frame. This is to create the main knowledge graph that we would be using from the data frame object. This is for plotting the knowledge graph. Fetch or create city. This is a gateway to check if the knowledge graph to check in the knowledge graph if a city exists or not. If it doesn't exist, then we need to generate the knowledge graph for that city. This is adding a selected attribute to the maps places. Get top k places is our main function. We are using the user input to filter the places and toggling the value of the selected to 0 or 1. If it's 1, then we are getting it as ticked, and if it's 0, then we are not. This is the path traversal, and we are reaching for the 3 hops in the node's proximity. This is a retriever model. The above one was the generation, and we are implementing the rack solution over here. This is the event planner. This is an agentic AI application that we are using. This is a demo text for few short prompting. This is a prompt, and this is the main code how it's running. The Python Flask API. These this is a list of the places that has already been visited, and we are adding the place after searching it for one time. These are some of the endpoints. This is the places endpoint. This is the top k places endpoints, and this is the event planner endpoint. And here we can run the Flask app using a threading operation. This is the code for my front end. Here we are using npm start to start the React app. This is a React based app with source code as follows. These are the components that I have made: card, event cards, event planner, flex cards, header, home page, modal, place selector, and text box. Thank you. That's all from my side. And as of my tech background, I am much involved into agentic AI, blockchain, and rack systems. I have earlier participated in many hackathons and won about 7 hackathons. So I think I make a perfect fit for this hackathon as well. Thank you.